Okay, next examples that we're going to look at here, and these examples would cover questions 39 and 40. The previous page's examples were covering questions 19 through 22 on your class kick. So this is questions 39 and 40. So what we're going to do is I'm only going to cover one or two of these questions. And you'll notice as you see the picture, the biggest key that you have to figure out, okay, what are they giving you in this picture? So in the picture, you'll notice you have a segment A, C. You notice that D is in between those two. And then you also have a segment E, B. And you also have D is in between those two. But you'll notice you have markings here. And these markings mean that whatever has the same marking as this is the same. So in this case, right now, because of the markings, you know that AD is congruent to DC. And you also know that ED is congruent to DB. The ones that have two markings, okay, this segment and this segment are equal. And then the ones that have one marking are equal. Okay, so in the first example it says if AD is 20, so AD is right here, that's 20 units long, and AC, that's the whole segment, is 3x plus 4, find the value of x. Then find AC and DC. I want to find out how long those two segments are. So let's take a look here. Let's label this. We know that A to D is 20 units long. Well, if you look at the picture, there's something in the picture again that'll give this away. You see this two markings right here. So you see that double marking. That means that that's the same length as well. So right now, we know right away, DC, you're 20 units long. Okay, so AC is the whole segment. Okay, we know that the whole segment is the part plus part, which in this case is 40. So what I'm going to do here is I'm going to say, okay, I know that AC, that's 3x plus 4. Okay, I know that that's 3x plus 4. And I know the whole thing is equal to 40 units because that is 20 and that's 20. That means the whole thing is 40. Now I can figure out what the value of x is. So I subtract 4 from each side. I get 3x equals, because the 4's go away, and that's going to be 36. And when I divide by 3, okay, x is going to equal 12 units. Well, that's great because x is 12, but I want to know how long AC and DC are. We already got AC, or we already got DC. AC, there's a couple ways I can do it. I can plug it back in. I can plug this into 3x plus 4, or I can take the two segments that I have. I know this length is 20, and I know this length is 20. And if I add those two together, they're going to be 40 total. Okay, so in that case, I use something like the segment addition postulate. Okay, second example says if ED is 5y plus 6 and DB is y plus 30, find the value of y. Then find ED, DB, and EB. Okay, so let's take a look here at these. So let's take a look here at ED. ED is 5y plus 6. That's this segment right here. That's 5y plus 6. DB is y plus 30. Okay, now, the trouble with this one is, do I know how long EB is? Do I know how long that is? I do not. So I cannot say part plus part equals whole because I don't know how long the whole segment is. But I do know that these markings mean that these two segments are equal. So D is in the middle, which means D is a midpoint. So I could say 5y plus 6 equals y plus 30. Those two segments are equal to each other. And again, I want to get y by itself. So I'm going to move the y. I want to get all the y's to one side first. That's going to be 4y plus 6, and that's going to equal 30. Then I'm going to subtract 6 from both sides, and 4y is going to equal 24. And then I'm going to divide by 4, and y is going to be 6. Now again, this would be great if that was my final answer, but they want to know how long ED, DB, and EB are. So I do have to plug these ones in. So 5 times 6 plus 6, and 5 times 6 is 30, plus 6 is 36. That's ED. Okay, ED is 36. Now, when I plug it back into the other one, if I take y in this case, that's 6, and I add that to 30, that's going to be 36, and that is segment DB. Well, if both segments are 36, I can take 36 part plus the part, and it's going to give me the whole, which is 72, and that's segment EB. Okay, now these examples should be able to complete problems, again, 19 through 22 and 39 to 40 on your examples on ClassKick. Now finally, let's take a look at number 4, the fourth example here, because it's a little bit slightly different as we look here. It says here on example number 4, we're not going to worry about number 3 for right now, because it's very similar to the other first two that we looked at, okay? But let's look at example number 4. In number 4, it says if EB is 4y minus 12 and ED is y plus 17, find the value of y, and then find the segments that are the following, ED, DB, and EB. Essentially find the 3 segments. What's different about this one is it gives you EB, which in this case is the whole segment. That's 4y minus 12. Okay, so EB is 4y minus 12. That's the whole segment. Then it gives you ED, and that's y plus 17. Okay, now what's different about this one, again, D is still the midpoint of segment EB, so D is still in the middle, but you'll notice, again, as you remember, these tick marks mean that these two segments are the same thing. So in this case, we're going to say that DB is also y plus 17. And what we're going to do to solve this one is we're going to say that it's part plus part equals whole. So even though you have a midpoint example, we're still going back to segment addition postulate. Okay, so in this case, I'm going to say on my problem that y plus 17, that's a part, plus the other part, y plus 17, equals the whole, which is 4y minus 12, which in this case, if you look at the left side of the equation, we can combine some like terms here. We've got y and a y, that's 2y. We've got a 17 and a 17, since they're both adding. We're going to add those two guys together. We're going to get 2y plus 34 equals 4y minus 12. And then we can try and get y by itself. So now I've got to use in this case, the subtraction property of equality. I want to get all the y's to one side, so I'm going to subtract 2y from each side. That means the 34 is the only thing that's left. 4y minus 2y is 2y. Bring down my negative 12. Now again, I want to get everything away from y, so I'm going to do the opposite, or in this case, I'm going to use the addition property of equality. We're going to add 12 to each side. And that's, that's not 30, that's 46 is going to be equal to 2y. And then finally, I finish it up by dividing by 2. And y is going to be 23. Okay, so in order to figure out ED, DB, and EB, I got to plug them back in. So in this case, Y plus 17, or 23 plus 17, that's going to be 40. So we'll count that as segment ED. Well, if ED is 40, then DB also has to be 40, because they're both Y plus 17. And then finally, I would take the 40, add it to the other 40. Part plus part is going to equal the whole, and the whole is 80, or which is segment EB. Okay, so this concludes the examples here for part 2 of the midpoints. So you should be able to complete those on your class kit.